I have a hard time figuring out how to begin this session because I deal more on the building automation side. So I'm not specifically industrial, but controls are controls. You need to secure them. You need to be able to lock things down to prevent any kind of attack. You've seen the big Target scam that happened, and they attacked through the BAS system because the BAS system was tied to their POS system at the same time, which you should never do. And I come from an IT background, so I'm that IT guy you guys love to hate. I used to practice all the same principles as all the other IT guys. It's, I'm gonna use all my technology to lock your stuff down. Well, that doesn't always work, especially when I moved into this position, which I'm dealing with building automation systems using a specific protocol called BACnet to talk to each other. And I first started, I'm like, I'll just start applying these IT principles. As soon as I did that, I started seeing problems and issues with it. And one of our constraints is I'm dealing with construction all the time. We just went through a $3.2 billion capital plan over the last 5 years, which will end in June. During that time, we got buildings half torn apart, half going, being renovated. There's a lot of movement happening. But one of the things, and they love this little phrase I came up with, the puck will drop. When they were building our Pagula ice arena, I was told consistently, the puck will drop. No matter what, whether the building was completely finished, all the safety factors were put into place, that game was going to happen on time, no matter what. So we spent a lot of time trying to get all that controls under control to meet that date. Here's some general data about Penn State. We have 24 campuses, 41 million square feet of building space across all locations. They have the World Campus now, which is online training or online schooling for 15K students. Faculty and staff were in the 40K mark this last year and dealing with over almost 100,000 students. Right now on University Park, we actually have 300 buildings out of the 900 rough buildings that they count, which counts as a shed is considered a building. A little cow shed is considered a building. So we have 1,000 some odd buildings on campus, but actually 300 of them are the ones that we deal with on a regular basis. Inside those buildings, we had a single flat layer 2 network spread across the whole infrastructure, all across the campus, with 4 different subnets that we were using, all /22s. So 4,000 plus IP addresses available to be utilized. What we moved to a couple years ago, we started a layer 3 network, and what we were trying to do is simplify the design, give better IP space to each building instead of this big flat layer 2 infrastructure. We have over 600 plus switches out there that we have to manage, maintain. We have a firewall that we're managing over 250 rules in the firewall from all these other individual buildings that are outside of our campus that need access to us. And we do a lot of the hosting infrastructure for those Commonwealth locations. Our environment changes drastically depending on the type of building. We have lab facilities, we have the vivariums, we have all these different spaces for research. One of our strict research requirements in one building alone, we had to maintain temperature within a 10-degree bubble over a period of time. And we actually had an incident where it went over 85 degrees for 5 minutes. That blew away 6 months of research in that time. Now, part of it was our fault, part of it was their fault. They decided to add a heating system using heat lamps that wasn't tied into anybody else. So we did not know that even though we shut down our air system, the heat was still being produced by those heat lamps. We have a precision equipment where they are doing an atomic clock research. And his room, he has very specific controls and humidity, temperature, pressure, everything inside that space. And no one is allowed to go inside the space. So we're constantly making sure that his equipment is running. We have rare specimens. We got ice, glacial ice or glacier ice that does not exist today. The cores are sitting in freezer units that we are strictly monitoring to make sure that they don't melt. As soon as there's an alarm on those, we have people rushing out there to make sure that those don't get damaged. We just had medical facility lost $40,000 worth of medical equipment because they overloaded the one unit because the other unit was failed. Well, by overloading that unit, they caused it to fail. So they lost $40,000 worth of medical specimens in a very short amount of time. And you can't respond. I mean, our earliest response is 30 minutes. And that's if the guy lives halfway down the block from the university. So amongst all that, then we start dealing with the construction projects and making sure that all the contractors can have access to their controls while they're building the buildings, making sure everything is maintained. Some of the buildings, like I said, are renovations, so there's actual people still working in these buildings as we're tearing down floors, removing equipment. And so we have to work around all that. One of the things we found was a wireless access point, a contractor plugged in one of the mechanical spaces, and it was backfeeding into our network, and that was the only reason we found it, is because it was backfeeding into our network. But he had a wide open using WEP on it to secure it down, which was cracked several years ago. But the contractors want to do the simplest, easy thing to get their job done, but not worrying about the security aspect. So how do I lock down all these mechanical spaces and all these closets and everything across the campus and be able to still utilize the tools that they need to do their job? You know, here's a picture of our construction from last summer. Everything in orange is everything that was being touched or modified during the summer program. And you can even see right in front of Beaver Stadium, they started moving parking lot space. They needed to get, an extra 12 spaces for those alumni that were, paying the money to do that. So here's the list of all the pieces that we're looking at, and we're trying to come up with the best solution. How do we block all these broadcast storms that we're getting? How do we lock down the telecom spaces? So we looked at all your traditional things, doing NAT and doing firewall rules, doing IPsec tunnels, put an actual individual firewall at every single building, looking at MAC filtering, looking at any kind of tools to be able to lock these things down. But they're very complex, and the time to implement some of them are drastic. I mean, we're looking at several years for us to deploy something very easily across the campus, and additional staff, and even just the equipment costs. Some of the vendors, their quotes were insane. It was unbelievable how much money is in this security realm. So what we started with was, I was in a meeting and someone mentioned the Hiep protocol. And I'm like, well, what is Hiep? And so I went out, researched it. I called that sales guy back the very next week and had him set up a meeting with Tempered to talk about it because it fit into our wheelhouse. It was exactly what we were looking for, a way to lock down between us and the building itself to make sure everything is secure. And so we deploy at the building level. Inside the building, we put a Hiep switch, and then all the controllers and everything plug back up into the Hiep switch. It's all centrally managed through a single platform called Conductor. That allows us to manage all these switches out there. We were able to deploy over 40 units to 40 buildings within a week. That is a significant deployment within such a short amount of time, and with only 8 people to do it. So we did a POC with it before we even did the deployment. We did a POC of it. We did about 5 buildings. I just handed it to my guys. I didn't even get training from Tempered or our reseller. We just put it in, started playing with it. My guys were able to set it up within 2 days. It is very intuitive. It's something easy, and that's what we were looking for. One way to just simply get this out there and secure the network. And so we're able to create the main overlay to the building from the data center, and then each individual system is locked down. So the lighting controller can talk to the lighting server. The building automation controls can talk to the building automation server. Elevators, you name it, we're bringing that data back through into our data center. Now we can channelize that overlay and create individual trust relationships between the device and the server it needs to get to. And with that, we've narrowed our attack vector almost by 90%. Because there is still the chance, you would have to assume the IP address of the controller, and then once you did that, then you had to figure out what IPs can I actually get to. So we're making it more difficult for them to do it, and that's usually, they're going to go for the easy wins. They're not going to spend days trying to search for where they can get to in the system. And it gets rid of a lot of that east to west traversing that they can do once they're on your network. Here's the conductor, and you can see each switch, and it deploys in several form factors. We're actually using every one of these right now. We have the Hiep switch physical out in the building. We're using the cloud solution to bring our cellular connections in through. We have 2 virtual Hiep switches set up in an HA pair inside the data center. We're using the Hiep server to lock down the client-side software, the web interface for the tools. And then client access, we're able to lock down our techs' laptops and prevent them from getting to the things that they're not supposed to get to. And they only can see the items that we allow them to. So the HVAC techs can only see the HVAC equipment. The lighting techs can only see the lighting systems. Here you can actually see that one of the nice tools inside the Conductor is this visualization. You can actually see the relationships between the devices. So you can see the electric meter gets to the power logic server. The elevator gets to the elevator server. Everything is segmented off, even though they're sharing one single VPN connection, basically. It's an ESP tunnel between the building and our data center. And then we create those trust relationships with the whitelisting of the devices. So even the lighting server, it only talks to what it needs to talk to. So again, here shows the cost comparisons. We started looking through what is this going to cost us? And then even on top of that, what does this scale out to? We're looking at costs over a 5-year period. We were able to find that with $500,000, we can do full deployment. To me, that was a significant win for us. They've worked with us to find that easy middle ground for us so that we're not having to hire the extra people and doing all the VPNs and firewalls and all the other pieces. And again, it's very simple to deploy. That was one of the unbelievable things. The sales guys laughed because the first time I got into the interface, I'm sitting there messing with it, and I started giggling like a little schoolgirl because this was the thing I was looking for. This fit everything that we wanted to do in a very short amount of time. And so in the end, we were able to dynamically decrease our deployment time. We were able to use their cellular device. In a construction environment, a lot of times the fiber is the last thing that's brought into that building. Now, I can put a cellular Hiep switch out there, get the building online way before they even got the fiber in the ground. And then we have another scenario is the cornfield scenario. We have a building that's in the middle of a cornfield, $100,000 to run fiber or cable to that building. The university's been back and forth on it for probably the last 6-7 months trying to determine whether it's worth that cost. I needed to get the building online and bring it in. I was able to use that cellular Hiep switch inside the building and get the controls now back to the system into the data center, so our techs can actually look at the system before going out there, then instead of spending the time driving all the way out, find the problem, figure it out, and then realize they need a part from back at the main office. Now they can do that kind of preliminary investigation right from their computers right at the main data center. And with the cloaking, it's one of the nice things, we can run over any commodity internet connection. It doesn't matter what is deployed between the locations. It's completely agnostic to it. So you're able to put it on a flat layer 2, a complete routable network, over cellular, it doesn't matter. It doesn't care. As long as the Hiep switch can ping the conductor, that's it. That is the main piece of it. And it's one single entry. That's one of the biggest things. We're now adding all these commonwealths and trying to get all their data and bring their systems under our data center. We have over 250 rules in there. I can take all those 250 rules and go delete. One single rule to allow the ESP tunnel traffic, which is 10,500. That is it. That is all I have poking a hole through my firewall. Now my attack vector is even smaller than it was before. We eliminated backnet storms. One of the things with backnet protocol, it's very chatty. We're able to segment each building into its own little bubble to help prevent that traffic from getting back to us, or even the data center traffic getting back to the building itself. We're able to minimize that broadcast domain. We're able to not increase our head count, and with the new layer 3 network, we're actually gaining even more flexibility in our infrastructure. So this is a summary of pretty much everything I've said up to this point. Is there any questions? Okay, later, okay.